Hello and welcome to Saurabh's classes. Today we'll discuss the IIT-JAM 2020 maths paper, and we start off with the first question, which says that there is a sequence Sn which is defined by two terms. The first one is a constant term 1 and the second term is a variable term which is defined by -1 to the power n divided by n, where n is a natural number, and we are asked whether this sequence is monotonically increasing or decreasing and whether it is converging. So there are two parts, whether it's increasing or decreasing and whether it's converging. Now obviously the first term, which is +1, has nothing to do with either the increase or decrease because it's a constant term. It cannot increase or decrease, and it will always converge to 1. So that is settled. Now let's look at the variable term. -1 to the power n divided by n has two components, which is -1 to the power n multiplied by 1 by n. And if we visualize these two curves, -1 to the power n, if I plot it as a function of n, will give me values of -1, +1 for consecutive values of n being ordered even. So n equal to 1 means this is fn is -1, n equal to 2 means fn is +1, and so on. So it will kind of oscillate between -1 and +1 for all values of n without converging. And if I plot the curve of 1 by n, now this is the curve of -1 to the power n, and if I plot 1 by n as a function against n, then I will get n equal to 1 and fn equal to 1. So that's my first point. And then for n equal to 2 it will be +half, n equal to 3 it will be 1/3, and for n equal to infinity this term will become 0. So that means this is converging but not continuous, it's a discrete function. And here we are talking about a superimposition of these two curves, which means that all we have to visualize is what will be the values at the first 2 or 3 points. So n equal to 1 means is a multiplication of this and this. So it's a sign and a value. So 1 into -1 is -1, and then n equal to 2 means half, and +1 means +half, and we continue in a similar fashion. So in every iteration or every increase in value, the sign of the function of -1 to the power n divided by n will oscillate between positive and negative, and the magnitude will decrease, so which means that eventually it will converge. So this is the concept, and if you understand this concept, then all you have to do is pick number C. It is neither monotonically increasing nor monotonically decreasing, but is converging to 1 because 1 is the constant here. If the function was not there, it would have converged to 0, as I am showing in this curve. So the answer to this question is C, which is neither increasing nor decreasing but will converge to 1. We go to question number 2. Here we are given a function fx which is defined as 2x minus 9x square plus 7, and then we are asked to check which of the following is true, and the choice is between whether it's one-on-one or not one-on-one. Now therefore we have to understand what one-on-one means, and if you Google up the internet, you'll see several definitions of fx1 is equal to fx2 implies x1 is equal to x2 and so on. But what is it in very simple terms? In very simple terms, it means that y or fx cannot take the same value for two different values of x. So this is what it means in very simple terms, and if I have to show you in terms of graphs, then for fx equal to any even function of x will mean that the curve will behave like this, and as you increase the power it will become like this, and then like this, and so on. And then if I look at this curve when n is odd, so this one is when n is even, and if I look at this curve when n is odd, then it will be like this for n equal to 1, and n equal to 3 will give you something like this. N equal to more than 3 will actually give you a curve something like this. So which means that for all even n, fx will have the same value for different values of x. So if n is even, then the function fx is not one-on-one. That means it will have different it will have the same value for different values of x. So that means it is not one-on-one. But whereas if n is odd, then fx will definitely have different values for different values of x. So in this case it is one-on-one, not one-on-one. So this is the basic concept. Now let us look at the given function. Now the given function is of the form x cubed and x squared. Now based on what I just told you, you will probably question me that we have both the functions here, so how will we handle this one? Yes, you are right. So the x cubed part will mean that the function will follow something like this, and the x square part will mean that the function will follow something like this, right? And it's a combination of both. So that means we can understand in very simple language that the curve will have a nature of this and this and then this, something like this. And why am I taking positive slope? Because the coefficient of x cube is positive. So if you calculate it mathematically, you can do it with differential, and you'll find the first derivative to be positive in a certain range, and you can work out the values there. So I'm trying to make you understand using concepts. So this is how it will behave. Now how do we determine the exact nature of a curve? We determine the exact nature of a curve by calculating the roots. That means where does it intersect the x-axis, and what is the value of y-axis when x is equal to 0, and definitely the slope of the curve or the nature of the curve around those intercepts. So let's try and do that here. So we'll first look at the derivative of fx, which is f dash x that comes out to be 6x square minus 18x, and as we all know, if we put this to 0, we'll find a maximum or minimum. That means x minus 3 or x minus 3 equal to 0 or x equal to 3 will be a point where the curve will change its slope. But notice one thing, that when I considered this point x equal to 3, I ignored the point of 6x. Basically, f dash x is equal to 6x into x minus 3, and I equated this to 0, and I took x minus 3 to be 0, but x can also be 0. So we have two solutions, which is x equal to 0 or 3. And at these 2 points, the curve will change its direction. Now look at the first derivative. Now we can clearly understand that any value below 0 will result in a positive value for f dash x. Why? Because x below 0 or x being negative will mean that minus 18x will be positive, and x squared is always positive. So the first derivative being positive means that the curve will be increasing anywhere below 0, x equal to 0, and for anywhere x equal to more than 3 will also mean that the curve is increasing after x equal to 3. So it will be something like this, and now we have to find what is happening to the curve between 0 and 3. Now the obvious question that comes to your mind is that, did I draw the curve correctly? No, I didn't. I was just trying to explain the concept, and what I ignored is the actual value of the curve, of the points in the curve. So at x equal to 0, my f dash x is 0, which is fine. That means my first derivative is 0. That means the curve will change direction. But what happens to the function at x equal to 0? It is equal to fx is equal to 7. That means it will be a curve like this, where it intercepts the y-axis at 0, 7. And what happens to the curve when x is equal to 3? This means that this is 54 plus 761 minus 81. So fx is equal to minus 21. Minus 20. So that means that at x equal to 3, it is at minus 20. So 3 minus 20 is the nature of the curve till here. And as we can see from f dash x, it takes the value of 0 between these 2 points, and therefore if I take any point in between, let's say I take x equal to 1, then f dash x will be equal to 6 minus 18, which is minus 12. That means anywhere between these 2 points, the curve or the function will be decreasing. So this will be the nature of the curve, which means that between x equal to 0 and x equal to 3, the nature of the curve reverses. And this is exactly the concept that you need to answer this question. So now we look at the options. F is 1 on 1 in the interval -1 and 1. So if I take -1 and 1, is F 1 on 1? We can clearly see that it's reversing trend at x equal to 0. So this is not correct. F is 1 on 1 in the interval 2 and 4. So 2 is somewhere here, 4 is somewhere here. So we can clearly see that there are points which will have the same value of y for different values of x. So this is not correct. Now we go to option 3. If f is not 1 on 1 in the interval -4 to 0. So -4 would be somewhere 1, 2, 3, 4. -4 would be somewhere here, and clearly f will have a single value for all values of x between -4 and 0. So this is not the correct option. Option D, f is not 1 on 1 in the interval 0 to 4. Not 1 on 1. Absolutely yes, because 0 to 4 means that it's following this path. So there will be several points where the value of y will be the same for different values of x, and that would mean that f is not 1 on 1. So option D is the correct choice. So guys, one thing important to note here is, as I said, there are two functions that are superimposed here. One is of the form of x cube, or an odd power of x, and the other one is x squared. And when we work it out, we see that the cube is dominating over most of the part, but wherever the first derivative is 0, within that the curve is changing its behavior, and that's where the x squared term kicks in. And this is the relevance of the combination of these terms in the overall function. We come to the third question. Now, looking at the question, you can easily understand that this is a question of limits, where they're hinting at L'Hospital's rule. It's very clear, and we can clearly make out from the first one, x over e to the power x, where limit x tends to infinity. Now, even if we don't know this rule, what will we do? We will just put the values of x as infinity in both the numerator and denominator, and we'll get infinity over infinity. And by logic, that should tend to 0, but because anything over infinity tends to 0, but just to be technically correct, this will be limit x to the x tending toward infinity, d of ddx of x by ddx of e to the power x, which will be nothing but limit x tends to infinity. ddx of x is 1, and ddx of e to the power x is e to the power x. So we now clearly get 1 over infinity, or 1 over limit tending to infinity, and that tends to 0. So this one is correct. If we look at the next one, this is nothing but a replication of the first option, because we can rearrange this as 1 by x by e to the power 1 by x, and this one tends to infinity as x tends to 0, and is very similar to the first option. So if we take 1 over x as y, then it exactly replicates the first option. Then as x tends to 0 plus y tends to infinity plus, and obviously if we apply L'Hospital's rule, it will be equal to 0. So this is also correct. The option C, very simple, because all you have to do is just put x equal to 0. So sine 0 is 0, and 1 plus 2 into 0 is 1. So there is no problem here. You get 0 straight away. Now we are left with the last option, and this is cos x over 1 plus 2x. Cos x at x equal to 0 or x tending towards 0 is infinity over 1 plus 2 into x, which is tending towards 0, means 1, which will tend to infinity and not 0. So this is the odd one out and is clearly the incorrect option. So option D is the right choice. We come to question number 4, which is talking about a differentiable function which is partially differentiable along x and y. And all we need to understand is that when you are differentiating with respect to x, you will ignore y or treat y as constant, and vice versa. So that's a simple rule, and we are given the function of f of x and y is equal to gy plus x g dashed y. So obviously when we differentiate this with respect to x, we'll only treat x as the variable and y as the constant. So the first term goes off and we'll just treat it as g dashed x, and ddx of x is 1, so that remains. And if we differentiate with regards to y, then we'll disregard x and we'll only consider y, so that will be g dashed y plus, we treat x as a constant, so x into g double dashed y. So now we get df dx and df dy, and we can use the differential of that, df dy minus df dx is equal to x g double dashed y, and that is nothing but, sorry, this will be g dash of y, not x. And if I differentiate this with regards to del x, rather del y, it will be del square f by del x del y is equal to g double dashed y. And if I put this value out here, then it becomes x into del square f by del x del y is equal to this value. So what we get is x del square f del x del y is equal to del f del y minus del f del x. That means del f del x plus x del square f sorry about the notation, del square f by del x del y is equal to del f del y, and this is the relationship that we derived at from the given equation, and we can see that del f del x plus x del square f del x del x del y is equal to del f del y is the right choice. So option C is the correct one.